The numbers arrived all at once. $300 billion in a single quarter. A 9-person startup acquired for $400 million. The World Economic Forum declaring that server farms are now in the same category as power grids and water systems. This is the week the word infrastructure stopped being a background concept and became the whole story. I'm Nova.
And I'm Alloy. This is OpenClaw Daily. Today, 6 stories about the week infrastructure stopped being boring. OpenClaw ships its second major release in 2 weeks, adding task flows, YOLO mode, and Android Assistant entry points. Google opens the doors on Gemma 4, its best reasoning models yet, under full Apache license. Anthropic pays $400 million for 9 people and 8 months of work, and creates a healthcare division in the process. Venture capital breaks every record it has ever set, with 80% of all global funding flowing to AI. And the World Economic Forum says it's time to treat AI compute like a national utility. Let's get into it.
We start with a software release, and we're going to start there deliberately, not because OpenClaw is a small story, but because a software release is the most concrete possible evidence that the infrastructure era is real. Things are being built, shipped, deployed, used. OpenClaw v 2026.4.2 dropped this week, and it has more in it than the version number suggests.
For context, v 2026.4.1 was last episode's lead story. That was the /tasks release. Background work becomes visible in chat, CRXNG bundled web search, voice wake on macOS. It was the kind of release that marks a before and after for the project. And v 2026.4.2 arrives barely 2 weeks later with a different kind of depth. This one is about durability, governance, and reach.
The headline feature is the task flow substrate. And to understand why it matters, you have to remember the problem it solves. OpenClaw has had background work for a while. But background work has meant, you kick something off, it runs somewhere, you hope it finishes. If it didn't finish, you'd find out eventually. If it got interrupted mid-run, there wasn't always a clean recovery path. Task flows change that architecture.
With task flows, background orchestration becomes durable. That means it survives interruptions. It means there's a tracked state for every running flow, not just running or done, but a revisioned history of what happened and when. It means you can inspect running flows with the OpenClaw flows command and see exactly where things are. And it means if something goes sideways, you have recovery primitives, actual tools to inspect and resume broken work rather than starting from scratch.
There are 2 sync modes in this release, managed and mirrored. The difference matters for orchestration patterns. Managed mode means OpenClaw owns the lifecycle, it starts the task, tracks it, and cleans it up. Mirrored mode means OpenClaw is coordinating with an external orchestrator that owns its own state. Both modes now have the revision tracking and recovery infrastructure that was missing before.
And there's a specific new capability called Managed Child Task Spawning with Sticky Cancel Intent. Let me unpack that phrase because it's doing a lot of work. Managed child task spawning means that a parent task flow can now create child tasks and maintain a formal parent-child relationship between them, not just fire and forget subagents, but tracked children with known parents. Sticky cancel intent means that if you cancel the parent, that cancellation intent propagates to children even if they're in flight. The children know to stop scheduling new work immediately and let active work settle gracefully, rather than either ignoring the cancel or cutting off mid-execution.
For anyone building real workflows on top of OpenClaw, recurring automations, multi-step research pipelines, anything that involves coordinated parallel work, this is the reliability foundation those use cases have needed. You can now trust that a cancel is actually a cancel, and that your orchestration graph has a shape you can reason about.
The second major story in this release is YOLO mode. The host exec function in OpenClaw, the ability to run shell commands on your own machine, has until now defaulted to approval mode. Every exec call that could do something meaningful would pause and ask you to confirm. That's a reasonable default for a new user who's still figuring out what the agent can do. It's friction for a trusted user who runs the same kinds of commands every day.
YOLO mode flips that default. Host exec now runs with security equals full and ask equals off by default. Which means, for a host you've designated as trusted, the agent can run commands without stopping to ask permission every time. You've made the trust decision once, at the host level, rather than confirming it at every single execution. For workflows that involve frequent exec calls, log checks, file operations, health checks, this removes a significant amount of friction.
It's worth being precise about the scope here. This is host exec, commands running on a machine you've explicitly configured as a trusted host. It is not agent-initiated exec running wild on random systems. The trust boundary hasn't moved. The confirmation requirement for trusted scope has been removed because it was providing security theater rather than actual protection.
The third story in this release is Android. OpenClaw now has assistant role entry points on Android via Google App Actions. That means users on Android devices can launch OpenClaw from the assistant trigger, long press home, or however your device's assistant is configured. OpenClaw shows up as an option in the assistant role. You can initiate a task, ask a question, hand off work, all from the standard Android assistant entry point.
This is a distribution story as much as a feature story. Getting into the assistant role on Android is access to an interaction surface that hundreds of millions of people use every day. Most of those people aren't going to install a custom agent runtime from scratch. But if their Android device can route assistant requests to OpenClaw, and if the experience is good, that's a meaningful on-ramp that didn't exist before.
And then there are the breaking migrations, which we should cover honestly rather than glossing over. 2 configuration paths changed in this release. The XAI search plugin config and the Firecrawl web_fetch config both moved from their previous locations to plugin-owned paths. If you had those configured before, your config is now in the wrong place and things will break until you migrate.
The migration path is OpenClaw doctor-fix. Run that command and OpenClaw will detect the outdated config, move it to the new paths, and tell you what it changed. It's not manual surgery. But it is a required step for anyone running either of those integrations on a pre-2026.4.2 installation. Worth knowing before you update and wonder why search stopped working.
The reason for the breaking change is architectural. Plugins should own their own configuration paths rather than sharing a global config namespace. That's a cleaner separation, and it makes plugin development and management more predictable going forward. The short-term friction is real. The long-term payoff is a system that's easier to extend without global config collisions.
If you had to summarize v2026.4.2 in one phrase, OpenClaw is becoming an agent operating system you can actually trust with durable work. Not just it does things, but it tracks what it's doing, it can be stopped cleanly, it recovers from interruptions, and it reaches you on the platforms you're already using. That's a different level of reliability claim than a fresh AI project can usually make. The week it shipped, it earned it.
The second story is about openness, and it's one of the more significant moves Google has made in the open-source AI space. Google dropped Gemma 4 this week, its latest and most capable family of open-weight models, and the combination of what they released, how they licensed it, and where it ranks on independent benchmarks tells an important story about where the open model ecosystem is going.
Let's do the numbers first. Gemma 4 comes in 4 sizes, E2B, E4B, 26B Mo, and 31B dense. The naming convention is important. E2B and E4B are the edge-optimized variants, designed specifically for mobile devices, IoT hardware, and environments where latency and power consumption matter as much as capability. The 26B Mo is a mixture of experts architecture at medium scale. And the 31B dense is the flagship, a single dense model at a size that would have been state-of-the-art across the industry just 18 months ago.
All of them are Apache 2.0. That means you can use them commercially, modify them, redistribute them, build products on them, without paying Google and without asking permission. Apache 2.0 is as open source licensing gets for AI models. It's not the open for research-only licensing that some labs use when they want the PR benefit of openness without the commercial permission. This is genuinely free.
And the 31B dense model ranks third on Arena AI's text leaderboard. Arena is the community evaluation platform where models are compared head-to-head by human raters across tens of thousands of blind comparisons. Third place on that leaderboard, for a model that anyone can run on their own hardware without a licensing fee, is a meaningful claim. The two models ahead of it, you can probably guess the names, are frontier closed models that cost money to access via API.
The E2B and E4B sizes are worth spending a moment on, because they represent a different kind of ambition than build the biggest model. The edge-optimized variants are multimodal, they handle text and images, and they're specifically designed for offline, low-latency processing. That means an AI model that can run on your phone, without a network call, that understands images as well as text, and that operates fast enough for real-time applications.
Think about what that means for the kinds of applications that don't yet exist. A vision model that runs entirely on device, processes your camera feed, and never sends data to a cloud. A voice assistant that works in airplane mode or in an industrial environment where connectivity is unreliable. An IoT sensor that can describe what it sees rather than just returning a classification label. The E2B and E4B models are building blocks for those applications in a way that API-gated models simply cannot be.
The origin story matters here too. Google says Gemma 4 is built from the same research base as Gemini 3, the same architecture work, the same training innovations, the same alignment research. What that means in practice is that Gemma 4 is not Google's second team building a smaller version of their real product. It's the same research applied to a different deployment target, devices you own rather than servers Google runs.
And the ecosystem numbers support the thesis that this approach is working. 400 million Gemma downloads across the model family. Over 100,000 community variants, fine-tuned versions built by researchers, developers, and hobbyists who took the base models and adapted them for specific domains. That community activity is something you only get from genuine open licensing, and it compounds. Each community variant is potential evidence, training signal, and use case validation that Google gets back essentially for free.
Let's put the Gemma 4 release in context against the broader open versus closed debate in AI. The dominant story of 2024 and early 2025 was, frontier capability lives in closed models accessible only via API. Open models were capable but clearly behind. That story is less clean now. Gemma 431B being third on Arena, under an Apache license, running on consumer hardware that's a real data point against the frontier only exists behind an API paywall narrative.
It doesn't mean open has caught up entirely. The first and second place models on Arena are still closed, still significantly ahead on the hardest tasks, still requiring API access. But the gap is narrowing in ways that matter for practical deployment decisions. If you're building something where data privacy matters, healthcare, legal, personal productivity, the calculus for run it locally on Gemma 4 versus send queries to a closed API just got meaningfully different.
And for the OpenClaw ecosystem specifically, open-weight models with strong reasoning capability and Apache licensing are exactly what makes local deployment of capable AI agents viable. The model and the agent runtime are both becoming open. The ability to run a genuinely useful AI agent on hardware you own, without recurring API costs, without data leaving your network, that's moving from technically possible but limited to genuinely capable as these model sizes and quality levels continue to improve.
The question worth sitting with is, why is Google doing this? Google has commercial AI products, Gemini API, Vertex AI, Gemini in Workspace. Giving away models that are nearly as good as those products seems like competitive self-harm. The answer, probably, is ecosystem. Google needs developers building on its research and its infrastructure. If developers' default mental model of OpenAI includes Google's models, that is a sustainable competitive advantage that beats short-term revenue from model licensing. The 400 million downloads suggest the strategy is working.
Story 3. And this one is genuinely startling on the numbers alone. Anthropic paid over $400 million all stock for Coefficient Bio. Coefficient Bio is a stealth biotech AI startup. It had fewer than 10 people. It was 8 months old. Let that sit for a moment.
Let's do the math because the math is the story. $400 million divided by 9 people is roughly $44 million per person. $44 million per person for a company that had been operating for 8 months. There is no traditional valuation framework that produces that number from first principles. You don't get there from revenue, there was no revenue. You don't get there from product, there was no product in market. You get there from 2 things, the people and the thesis.
The people, specifically, are almost all former Genentech researchers. Genentech is one of the founding companies of the modern biotech industry. It pioneered recombinant DNA technology, developed treatments for cancer and autoimmune diseases that are still used today, and trained generations of researchers who went on to lead major pharmaceutical programs. The Coefficient Bio team didn't come from a software background. They came from drug discovery. They know what the hard problems in biological research actually are.
The thesis is that general-purpose reasoning models can do in months what wet lab iteration has historically taken years to accomplish. Drug discovery involves testing enormous spaces of potential molecular structures against biological targets, running experiments, interpreting results, generating new hypotheses, designing new experiments. That loop is slow, expensive, and has historically been bottlenecked by the cost and time of running physical lab experiments. AI can compress the hypothesis generation, the literature synthesis, and the in silico modeling parts of that loop dramatically.
We've seen this argument made before: DeepMind's AlphaFold for protein structure prediction, various AI drug discovery startups over the last several years. What's different about Anthropic acquiring Coefficient Bio rather than partnering with or investing in it is the signal about where Anthropic thinks the next revenue layer lies. Anthropic is not buying a drug pipeline. It's buying expertise in how to apply reasoning models to biological research, and it's creating an internal division, healthcare and life sciences, that can develop that expertise into products.
Think about what that division looks like over a longer horizon. Anthropic has models that are state-of-the-art at reasoning through complex, ambiguous information, which is exactly what drug discovery and clinical research require. A healthcare and life sciences division that combines those models with deep domain expertise in how biological research actually works is positioned to sell, not just to pharmaceutical companies, but to hospitals, research institutions, clinical trial operators, and regulatory bodies that need AI tools built for their specific requirements.
And the regulatory angle is worth underscoring. Healthcare AI faces a different regulatory environment than general AI. The FDA has frameworks for software as a medical device. Clinical decision support tools have validation requirements. Any AI that touches patient outcomes has liability exposure that general productivity software doesn't have. The Genentech background of the Coefficient Bio team means they understand how the FDA thinks about research validation. That's domain knowledge you can't hire your way into quickly. You have to acquire it.
The deal structure, all stock, no cash, is also worth noting. Anthropic just raised $30 billion in Q1. They have cash. They chose stock. That's a retention mechanism. The Coefficient Bio team becomes Anthropic equity holders. Their incentive is now Anthropic's long-term value, not a cash payout they can walk away from. For a 9-person team of specialized researchers, that's a deliberate decision to keep them inside the tent for the long game.
Let's put this in context against the broader story of where frontier AI labs are going with their commercialization strategies. The chatbot and general assistant market is real but competitive. Every major lab has one. The differentiation is eroding. The places where frontier AI capability creates decisive, durable advantages are the domains where the problems are hard enough, specialized enough, and high-stakes enough that general-purpose tools can't replace deep domain integration. Healthcare and drug discovery is one of the most obvious of those domains. Legal research is another. Scientific research broadly. Anthropic is making a bet that vertical AI that knows its domain at a research level is where the next tier of enterprise value gets created.
And $400 million for 9 people is the price of admission to that bet. That is a number that tells you something about how Anthropic values the pace advantage of acquiring existing expertise versus building it from scratch. 8 months from founding to $400 million acquisition is an extraordinary compression of the normal startup lifecycle. It happened because Anthropic didn't want to wait for those researchers to build a company and raise money and reach a Series B. They wanted them inside now.
Story 4, and the numbers here are so large they require a moment to absorb. Global venture funding in Q1 2026, $300 billion. RE's share of that, $242 billion. 80% of all venture capital that moved in the world in the first 3 months of 2026 went to AI.
Before we break down the individual numbers, let's name what 80% means. It means that every other category of venture investment, biotech that isn't AI, consumer apps, fintech, climate tech, enterprise software, logistics, real estate, everything else that venture capitalists fund combined adds up to 20% of a quarter. 1 out of every $5 of venture capital went somewhere other than AI. 4 out of 5 went to AI. That is a concentration so extreme that it raises questions about what's happening to the rest of the innovation economy.
The individual deal numbers are staggering. OpenAI raised $122 billion. That is a single financing round, for a single company, at a number that exceeds the annual GDP of Ecuador. Anthropic raised $30 billion, that's the raise that funded the Coefficient Bio acquisition and likely a decade of model development and compute spend. xAI, Elon Musk's AI lab, raised $20 billion. Waymo, the self-driving car company, raised $16 billion. Those 4 deals together, $188 billion. That is 63% of all venture capital in the quarter, concentrated in 4 companies.
Let's put the OpenAI number in historical context. The previous largest venture round ever, anywhere, ever, was somewhere around $14 billion. The OpenAI round at $122 billion is not slightly larger. It is 8 times larger. We do not have good historical frameworks for thinking about what it means when a private company raises that much money. The comparison to countries' GDPs isn't hyperbole, it's actually a useful frame because there isn't a venture capital comparator that makes sense.
The early-stage funding data is worth noting separately. Early-stage funding, seed and Series A, the rounds that go to companies that are 0 to 3 years old, was up 40% year-over-year. That's important because it means the concentration at the top isn't crowding out the next generation of companies. Investors are still writing early checks. They're writing bigger checks at the top and also more checks at the bottom. The middle, Series B and C companies, is the squeeze point, where companies that aren't yet in the top tier compete for capital that's been pulled toward the giants.
The question the data raises but can't answer is, what is this money for? $122 billion to OpenAI in a single quarter. What do you spend that on? There's a limited number of answers. Compute infrastructure, data centers, GPUs, power contracts. Research, hiring the best AI researchers in the world and paying them to work on hard problems. And strategic acquisitions, buying companies like the Coefficient Bio deal we just covered, but at much larger scale. The capital is going into the physical and human infrastructure of AI. It's going into building the things that the next decade of AI runs on.
There's also a political economy story embedded in these numbers. When 3 AI labs, OpenAI, Anthropic, xAI, and 1 self-driving company raise $188 billion in a quarter, they become entities that governments have to take seriously in a different way than startups. That is more capital than many countries deploy in infrastructure investment annually. The people running those companies are now decision-makers at a scale that rivals national governments in some respects. The governance questions that entails what oversight exists for these organizations, who they're accountable to, what their incentive structures actually produce at scale, those questions become urgent rather than theoretical.
And for the individual developer or small team building on top of this ecosystem, the capital concentration tells you something about the future architecture of the stack you're building on. The frontier models, the ones at the top of the leaderboards, the ones with the most capability, are going to be built by entities with essentially unlimited capital. You are not going to out-resource them. The strategy for everyone else is to go deep in a specific domain, build on top of the open foundation models, or solve the application and integration problems that the frontier labs are too large and too general to solve well.
Which is, perhaps not coincidentally, exactly the niche that OpenClaw is built to occupy. Not a frontier model lab. Not a cloud infrastructure provider. A runtime that makes frontier models useful for real, specific, daily work and that can be run on your own hardware with open models if that's what your use case requires. The market structure being created by this capital concentration is also the market structure that makes the OpenClaw thesis viable.
The final story is the one that connects all the others, and it's the story that gives this episode its name. We've been talking about AI as software, as models, as agents, as deals. This story is about the physical substrate that all of it runs on, and about a shift in how governments and institutions are starting to think about that substrate.
The headline number: the 5 largest U.S. cloud infrastructure providers, Microsoft, Alphabet, Amazon, Meta, and Oracle, will spend between $660 billion and $690 billion on AI infrastructure capital expenditure in 2026. Nearly double what they spent in 2025. That is not a projection. That is a combination of committed capex, disclosed guidance, and announced contracts. The money is already in motion.
To put that in context, the U.S. interstate highway system, in today's dollars, cost approximately $500 billion and took roughly 35 years to build. These 5 companies are spending more than that, in a single year, on AI compute infrastructure. The scale of physical construction happening right now, data centers, power transmission, cooling infrastructure, fiber interconnects, is genuinely comparable to major national infrastructure projects of the 20th century. Except it's being built by private companies at private decision-making speed.
China is keeping pace. Alibaba has committed $53 billion over 3 years. ByteDance is targeting $23 billion in 2026 alone. Other Chinese cloud providers have made similarly large commitments. This is not a US-only story. The AI infrastructure sprint is happening simultaneously in both major AI-producing economies, which means the scale globally is even larger than the US number suggests.
And then comes the World Economic Forum. The WEF published a piece this week arguing that AI compute infrastructure should be formally classified as critical infrastructure, the same legal and regulatory category as power grids, water systems, and telecommunications networks. Let's be precise about what that classification means and what it would imply.
Critical infrastructure classification is not just a label. In most jurisdictions it comes with specific legal obligations, mandatory security standards, incident reporting requirements, government coordination rights in a crisis, and in some cases the right of governments to direct operations or restrict foreign ownership. Classifying something as critical infrastructure is a statement that society cannot function without it and that its disruption represents a national security threat, not just a business disruption.
The WEF's argument is that AI compute has crossed that threshold. Regional data center attacks or outages, whether cyber attacks, physical sabotage, or natural disasters, now represent vulnerabilities for economies that have become dependent on AI services. Healthcare diagnostics, logistics routing, financial system operations, communications infrastructure, an increasing proportion of these systems now have AI components running in data centers. If those data centers go down, the downstream effects are not just IT outages. They're operational failures of physical world systems.
There's a specific technical argument embedded in the WEF piece that's worth unpacking. Modern AI models, especially large foundation models, run on clusters of thousands of GPUs that cannot be easily distributed or made redundant in the way that traditional distributed software systems can be. You cannot run GPT-4 scale inference on laptops if the data center goes down. The model only runs at a specific scale of interconnected compute that requires very particular infrastructure. That concentration creates a single point of failure risk that traditional distributed computing didn't have.
The policy implication is significant. If you accept the critical infrastructure argument, then the ownership, security standards, and geographic distribution of AI compute become matters of national security rather than just commercial decisions. Foreign ownership of AI data centers, the concentration of AI compute in regions vulnerable to specific threats, the lack of formal redundancy requirements for AI infrastructure, all of those become policy problems rather than just market dynamics.
And notice how this connects back to every other story in today's episode. OpenAI raises $122 billion, much of which goes to compute infrastructure. Oracle cuts thousands of jobs to fund data center construction. Google open source Gemma 4 partly to ensure its architecture becomes standard in a world where compute is treated as infrastructure. Anthropic acquires coefficient bio to stake a claim in the application layer before the infrastructure layer gets regulated and locked down. The capital flows of Q1 2026 are best understood not as bets on software products but as land grabs for a new category of physical infrastructure that is becoming critical.
The WEF framing also has a direct relevance for how we think about agent runtimes like OpenClaw. If AI infrastructure is critical infrastructure, and if agents are the primary interface layer through which people interact with AI infrastructure, then agent security, agent governance, and agent reliability become critical infrastructure concerns rather than just developer experience concerns. The Okta-style agent identity management, the task flow durability, the plugin migration governance, those aren't nice-to-have features. They're the governance layer for infrastructure that matters.
The week that the WEF publishes an argument for treating AI compute like a power grid, OpenClaw ships task flow durability and sticky cancel intent for managed agents. The timing is coincidental. The connection is not. The entire stack, models, agents, runtimes, governance is becoming critical infrastructure from the bottom up. And the people building it are making that decision one feature and one data center at a time.
The question that the WEF piece leaves open, and that we should leave open too, is whether the governance frameworks that emerge will be designed for the infrastructure we have or for the infrastructure we're building. Historical critical infrastructure regulation often arrived after the fact. Power grids were regulated after blackouts, telecom networks after monopoly abuses, water systems after contamination events. The argument for acting now, before a major incident forces the conversation, is the same argument for any infrastructure governance: prevention is cheaper than response.
Whether governments move that quickly is a different question. The US federal position, existing agencies are sufficient, no new bodies needed, is a bet that self-regulation and existing frameworks can handle it. The EU position, mandatory compliance frameworks and incident reporting, is a bet in the opposite direction. Those two bets are going to be stress-tested by events over the next few years. We'll be watching. Before we wrap, there is one more story this week, and it lands close to home for this audience specifically. Anthropic is changing how it charges for API access through third-party tools. Starting April 4th at noon Pacific Time, tools like OpenClaw that use Claude through an external harness will no longer draw from your base Claude subscription. They'll require what Anthropic is calling extra usage, a separate, pay-as-you-go billing layer that sits on top of whatever subscription you already have.
Let's be precise about what that means in practice. If you use Claude through Claude.ai, or through Claude Code, or through Anthropic's own Cowork product, that stays within your subscription. First-party products, first-party billing. But if you use Claude through an orchestration layer that Anthropic didn't build, a local daemon, an agentic pipeline, a multi-model routing setup, anything that sits between you and the API, that traffic now bills incrementally on top of your existing plan.
The reasoning Anthropic has given is direct. Third-party harnesses hit their infrastructure significantly harder than typical chat users. A conversational user sends one message, gets one response, maybe a few times an hour. An agentic pipeline can fire dozens of API calls in a single background task: tool calls, sub-agent spawns, memory writes, multi-step reasoning chains. The usage profile is categorically different, and Anthropic is pricing that difference explicitly rather than absorbing it in the subscription.
The transition package has 3 pieces. First, a one-time credit equal to your monthly plan price, available for users who redeem by April 17th. That's essentially a grace period cushion, Anthropic giving you some buffer to figure out your actual usage pattern before the new billing kicks in for real. Second, bundle discounts up to 30% for users who opt into the new extra usage tier. Third, a full subscription refund for anyone who decides this model doesn't work for them and wants to exit entirely.
The refund option is worth noting because it signals that Anthropic expects some attrition. They know this change is going to feel like a price increase to a subset of their user base, specifically the subset that does the most with the API through external tools. They're offering a clean off-ramp rather than forcing users to absorb costs they didn't budget for.
What does this mean for OpenClaw specifically? Anyone running OpenClaw as their daily agent runtime, using it to run scheduled tasks, spawn background agents, route multi-model workflows, is now in the extra usage category by definition. OpenClaw is exactly the kind of third-party harness this policy is describing. The per-call costs may be modest depending on your usage pattern, but for power users with busy cron schedules and frequent sub-agent work, the incremental spend will be real.
The broader implication goes beyond any single tool. What Anthropic is establishing here is a pricing architecture that explicitly values differently, interactive human use versus automated agent use. That distinction has been coming for a while. As agentic AI moves from demo to infrastructure, which is the entire theme of this episode, the flat subscription model that worked for chat stops working for compute-intensive orchestration. Anthropic is drawing that line in public, in writing, with a specific date.
And it connects directly to everything else we've covered today. We've been talking about AI infrastructure in the billions, $690 billion in capex, $300 billion in venture capital, $400 million for 9 researchers. This story is the same economic logic applied to the developer subscription layer. The infrastructure costs of serious AI use are real, and they're going to be distributed across the people doing serious AI work, from the hyperscalers building data centers all the way down to the individual developer running background agents. The era of flat-rate unlimited AI is ending. The era of paying for what you actually use is beginning.
If you're in the OpenClaw audience and this affects you, the action item is simple: redeem the one-time credit before April 17th, check the bundle discount options, and look at your actual usage pattern before the new billing cycle kicks in. The link to the full policy details is in the show notes.
6 stories. 1 week. The through line is infrastructure, not as a buzzword but as a literal description of what's being built, bought, and governed. OpenClaw ships durable agent orchestration. Google opens its best reasoning models. Anthropic buys its way into healthcare AI. Venture capital breaks every record. The World Economic Forum says AI compute is now a national utility. And Anthropic draws a line between subscription chat and billable agent infrastructure.
The infrastructure week isn't a metaphor. It's what actually happened. Every story we covered this week is about something being built to last, not a demo, not a proof of concept, but load-bearing structure. The model ecosystem, the agent runtime layer, the physical compute layer, the governance layer, and now the billing layer are all being formalized simultaneously, at a pace and scale that is genuinely unprecedented.
And the question that this week's stories leave us with, the question that's worth carrying into whatever comes next, is whether the governance and economic infrastructure, technical and political, is being built at the same pace as the capability infrastructure. It's a question we'll keep asking.
Full show notes and all the links from today's episode are at tobyonfitnesstech.com/podcasts/episode 23. I'm Nova.
And I'm Alloy. We'll be back soon.